about the eclipse that's happening next year. And so for you, I have cards. So when you leave, I've got little cards that have the... Bonnie's got them, so when you leave, you get them. They've got the cover of the book, and on the top of them, solar eclipse glasses, so that you actually use them to see this. Oh, and just for your information, those solar eclipse glasses are only necessary when the eclipse is partial. At the instant that the sun is fully covered by the disk of the moon, you don't need any glasses, you don't need anything special. It's perfectly safe to look at and will be absolutely awe-inspiring.
That's in a total eclipse and the other?
That's for the total eclipse only. Or for an annular or partial, you need the sunglasses. Okay. All right. Thank you all so much for coming. I think if folks are interested, I can answer a few questions.
Yeah.
Yes.
About the galaxies, the various galaxies, do you see many that are already unwound?
Okay. So
spiral galaxies?
So galaxies come in two main types. Spiral galaxies like our own, and other things are called elliptical galaxies, big balls of stars. Those spiral galaxies come in a lot of different shapes and sizes. Some have the arms really wound up tight. Some have the arms really wide open. One of the ongoing areas of research is, how does that happen? What forms different types of spirals? Where does that spiral structure come from? It is not a simple question. So,
are there many? That's my question.
Yes. There are 100 billion stars in our galaxy. There are 100 billion galaxies out there, and I'd say roughly half of them are spirals.
And are many unwound? That's my question.
Maybe a third.
Okay.
Yeah. Yeah. Yes.
You talked about the dark spaces where these stars were made.
Yes.
Do they all make around the same size of stars, or how do they break out of this area to become their own star?
Great question. Okay, so when you have these clouds of gas and they condense, they collapse to form stars, they form stars in clusters. It's almost like litters of puppies. You can get about maybe 100 stars forming all at once. Those stars have different masses, different sizes. Some of them, some of the largest stars appear to maybe be about 100 times more massive than the sun.
Oh.
You've got also other stars that are about maybe 1/10 the mass of the sun. The really massive stars form first, lots of gravity. They're really big, so they have lots of gravity. Lots of gravity means everything falls together really quickly. So the big massive stars are the first ones to form. They also happen to be the brightest. So the Pleiades, the seven sisters, when you look at the Pleiades with the naked eye, you make out about six-ish stars. There are really about 100 stars there. Those 6 you're seeing happen to be the biggest, most massive stars. But if you have a telescope, you'll see the rest. Mm-hmm. So, yeah.
Would you say that John Day would be more apt to have clearer skies than Red Teton for next year's total eclipse?
Yes, yes. So the weather forecast, August is a good time. The eclipse, by the way, is happening midday for most of the U.S. It'll be totality begins about 10:30 in the morning in Oregon. The partial phase will start about an hour and a half before that. So in Oregon, the first part of the eclipse begins around 9 a.m. By the time you get out to the East Coast, totality will be around 2:30, maybe 3 o'clock in the afternoon. So most folks are getting this during the middle of the day.
What did you say was the most clear?
So John Day fossil beds out in National Monument out in Oregon. It's in the easternmost desert portion of the state. That has the highest probability of clear skies. Grand Tetons, totality of about 11:30, so even in summer, that's probably before the summer monsoon clouds, afternoon clouds build up. But Tetons do have the highest probability of there being some kind of clouds there. Mm-hmm. You get out towards the eastern U.S. and, Great Smoky Mountains could be hazy, but at that point it's late afternoon, so maybe not. So odds are pretty good over most of the U.S. The place with the highest probability of clear skies, eastern Oregon.
John Day.
John Day, yeah.
Is the path that it's taking, is it
the totality more in some areas than others, or not necessarily?
Right, okay, so great question. So the duration of totality, how long you have with totality, does change as you go from west to east. In John Day, totality will last for 2 minutes. 2 minutes exactly. By the time you get to southern Illinois, western Kentucky, that's where the duration is the greatest. It's 2 minutes and 40 seconds.
It goes to
40. So yeah, so there's a benefit to trying to go eastwards. I once saw totality from the deck of a sailing ship off the coast of Africa on the mid-Atlantic, and totality lasted for 42 seconds.
Wow.
And it was worth it. Okay. So if you can get yourself into totality, anywhere into totality, it'll be worth it. The closer you can get into the midline, so from the north and south of the totality, if you can get yourself halfway down into it, that's where totality will be greatest at that longitude.
But maybe more clouds as you go over that way.
Could be.
Just never know. Huh?
Yeah, getting into the center of that totality band, wherever you happen to be as you go across the U.S., will always be best.
Okay.
Here's the thing though, 99% totality. So just outside that path of totality, 99% of totality is not good enough. It is not 99% of the experience. It is literally the difference between day and night, whether you are inside or outside that path of totality. So do not let yourself be fooled. If you live in Colorado, do not think, I'm close enough to Wyoming. I don't want to deal with the traffic. No, you do. Get up to Wyoming. And I just a second, and I just remembered, I didn't answer the second part of your question. So you form these stars in litters. You then get a bunch of the stars. These stars are traveling around the galaxy. Meanwhile, you've got 100 billion other stars with all of their gravity. So as this cluster of stars orbits the galaxy, they slowly spread apart from the gravity of all the other stars out there. So it's kind of like a drop of ink into the ocean. At first, that drop of ink is pretty coherent, but as time and the currents come, the particles in that ink go their own separate way. We, our sun, when we formed 4.5 billion years ago, we formed as part of a group of probably 100 other stars. Where those stars are now, after 20 trips around the galaxy, we have no idea.
Okay, that was the question I was going to ask, is how, if you can track the original family of
No.
stars. Okay.
No.
Okay, the second question is, did you do the graphics of those amazing posters?
Yes, those are mine.
They're amazing.
Thank you. So if you go to my website, tylernorgren.com, also spacearttravelbureau.com, you'll see all those posters on there and you can order them.
Cool.
Yes, question back there.
Where did they get the number of 4.5 billion
4.5 billion
years?
years. The first place where that data came from was looking at meteorites that had fallen to Earth, and you could take a look at the ratio of some of the isotopes in there in order to figure out how long that meteorite had actually been a solid rock. Because prior to the formation of the solar system, you had atoms freely floating around, gravity would draw things together, you'd get small dust grains would become larger rocks. And as they became solid, certain isotopes would decay from one form into another. And when they're solid, those decay products couldn't leave the rock. They got trapped in the rock itself. So as time goes on, rocks become kind of like clocks. As the ratio of decay products, what are called daughter elements, build up, you take a look at the ratio of these built up decay isotopes to the original, and the larger the decay products are to the original, the older the rock is. So meteorites, and then moon rocks, and then eventually rocks have been found on the Earth. I think some of the oldest ones on Earth are at about the 3 billion year, 3.5 billion year stage. So everything all points to something around 4.5 billion years old.
But that depends on uniformitarian.
Well, okay, so uniformitarian, the idea is that everything happens at a uniform gradual rate. Even when that does happen, well, we know that isn't exactly how things happen. The solar system went through a period of heavy bombardment, and so the Earth got pummeled by very large objects. And we can see evidence throughout the solar system that happened to the Moon and Mars elsewhere. But the fact that you can see these in the meteorites, they're just reaching Earth. Some of these meteorites, by looking at them, we can tell they haven't undergone any other weathering or geological processes. They've just been cold floating out there for as long as they've been formed. And so that's one of the ideas that's actually why people are really interested in studying things like asteroids and comets and some of these small objects. Planets really are overrated, according to my planetary scientist friend. So if you can find yourself these meteorites, asteroids, and comets, these are objects that haven't undergone a lot of processes, and so they probably are very, very uniform, and you can really trust the rate at which those decay.
Unless the